Okay, it's starting about now.
Okay.
I think it started recording. Oh no, we don't have YouTube yet.
Yeah, we do. Oh, I do.
Are we on?
Yep.
I'm getting a record.
Oh my God. Everybody, welcome aboard episode number 106 as we start our third year of telecasting. I get to say that word instead of broadcasting, the SBAU Astro Hour, our weekly foray into the incredibly fascinating field of cosmology and astrophysics, the outer space around us, including new theories, discoveries, NASA and other countries' launches, this week's night sky, stars and galaxies, our sun, solar system, stuff embraced by the South Coast Longtime Astronomical and Telescope Club, SBAU, Santa Barbara Astronomical Unit. I'm vice president of the club, very proud to host this program going into our third year. You can watch us on YouTube, although 20 seconds later. That's okay. And past programs, remember SBAU.org. Ron Heron is my name. Here's President Jerry Wilson to my left on the screen. 5 years now, 6 years. You know,
6
years.
2017 was my first year as president.
All right.
Like
when did I come on board? We decided when we lost Adrian Lopez that I would be the vice president, or I'd run for it because it's a very hot field, very contested. And there's our incredible outreach coordinator, Chuck McPartland. Nobody outreaches like Chuck, and his wife, Pat, is merchandise manager. Jerry Wilson, Friday night at our big meeting, brought his beautiful wife, Pat Forgy, along. They're all supporters. And son of a gun, here is Tom Whittemore, former Westmont College science instructor, editor of our Class Act newsletter. You get online. His wife is Maureen. And we don't have spam collector. That's the email address of one Bruce Murdoch until he, I guess, logs in late. This week, we're going to talk about a connection they're saying exists between dark energy, get this, and black holes. And we're going to kick around things like cosmological coupling, vacuum energy. We're going to look at a full moon called the worm. We got a worm moon out there tomorrow, I think. You had the wrong date in your talking points. I think tomorrow's the 7th, not the 4th. Wild duck star cluster, a variable star of the month. Oh God, we got one in Gemini. Auriga, the charioteer constellation. Know very little about it. Here he comes. I think he's logging in right now. A metal-rich galaxy, only, let's see, 1.5 billion light years old. That's younger than our solar system.
Just years old.
What? Years old, yeah. A light year's a distance.
Oh, I put light years. Let me understand something after our speaker gave us. Oh, there's Bruce. Hello, Bruce.
Hello.
Murdoch. Good to have you aboard.
Yes, good to be aboard.
I call these guys the Brain Trust. They know more than I do, and that's why I'm here. I'm like the little kid in Mr. Wizard's lab on Saturday morning back in the 50s. Gee, Mr. Wizard, no kidding? Is that how that works? Are all elements above helium and lithium called metals?
For the purposes
hydrogen
of
and
this
helium.
conversation, they were.
All right, Chuck.
Hydrogen, anything above hydrogen and helium is a metal to astronomers. And you're
Okay.
taking metal way too literally. It's just, think of it as just a term, not as a piece of shiny hard stuff.
Well,
Yeah,
I ask
don't
all
get
my regular
confused.
layman friends, and they think metals are hard, shiny things that conduct electricity. Silicon's
Sure.
not a metal.
There are three kinds of elements that are in the periodic table: conductors, semiconductors, and insulators. And the conductors are metals, but for purposes of his discussion, and he made that point several times, anything above helium is a metal, no matter
Okay.
what the rest of the community calls it.
The rest of the world doesn't know that. And I'm
Well,
still part of it.
he's not
Astronomers do.
interested in that. Let's put it that way.
Well, we're enlightened. Got to tell you, a young man who is leaving our museum, I guess he's our astronomy presenter by the name of Raphael Stavros Kottam, gave a talk. There's the sillies. These are 400 silly science cartoons from President Jerry. That's the duck on the calculator.
Yeah, this fellow has added one new excuse to his list of excuses.
That's better than the dog ate my homework. And there's a
Which I have used before.
calculator.
Bring in a bunch of shredded paper for them, right?
Yeah.
Doesn't look like any calculator. Oh, here we go. These are 4 stages of listening to a lecture. Staying up.
1,
partying.
2, 3, 4.
There you
I'm going to
go.
actually use that one this week because I'm giving a talk and I'm going to put that one up at the beginning.
Okay.
I'll hit you in a minute with outreach. Here we go. A couple is looking at, it doesn't look like the night sky, is it?
Yeah, it's
Yeah.
Jupiter and Venus
Oh,
Close.
that's right.
a degree apart.
She says, maybe Jupiter and Venus will never kiss. Maybe Jupiter and Venus are just really good friends.
Yeah, she's putting her boyfriend off.
Okay, it's a May-December romance of those 2 planets.
I
Did
don't
you
think
guys
it's gonna
see
be
it?
a romance.
Are they
Did you
far?
guys, did you
Are they
guys see
far-
it last Wednesday?
Say again?
Did you guys see that last Wednesday? I got
Oh.
a couple of pictures with my phone.
Yeah.
We
Points
were
are-
out at a school
night.
with telescopes and there was a huge cloud just sitting right over them.
Oh, bummer.
It's just beautiful.
So they
Yeah.
occulted? Is that what
No.
you're
Is that-
saying? They didn't occult. This is a funny one, a cute one. Tall buildings with stuff on top, usually big tanks of water or maybe AC units perched on legs. Downtown roofs would never know. Well, they haven't noticed it yet.
That looks like Chicago's skyline. They've got water
Oh,
tanks in the
those
top of
tanks,
most
yeah.
buildings.
New York used to have them a lot, but I don't see that they have that, at least outside anymore.
Wasn't the plot of Towering Inferno that there was a big tank of water that was on the roof? I didn't even know that, and they exploded it. Here's where
Yeah.
to look at your navel.
Yeah.
Pretty bad.
That's it. Naval Observatory, spelled a little different. All
Yeah.
right. Oh, this is today's horoscope. Stars and planets will not affect your life in any way. And
There's
yet
there's a website called something like Math is Special or whatever, and they did a meta-analysis of horoscopes for the different signs from newspapers all across the US, and they blended them together and made your generic horoscope, and it basically looks a lot like this.
just whatever horoscope person, oh, here's what happens to the figure 8 when it lies on its side, turns 90 degrees. It becomes infinity. No
Infinity.
thanks. I lie down, we never finish. Boy, I don't know. Here is the Wall Plugs family in their living room. Mom and dad on the couch, male, female, sitting beside him.
It's big, it's a massive pun.
Yeah, disciplining their 2-pronged sons. Says, Sparky, your mother and I are shocked at your current behavior. Until you learn to conduct yourself properly, you're grounded.
But you notice that the mother and father don't have the ground pin.
Oh, they don't, do they? They're
The
old
father
fashioned.
did.
Yeah, the father, they both have sockets. She has a socket. He
All
has
right.
the pin.
All right, it's there, just barely.
Barely, okay.
All right. And let's see.
I think
what do
we put this one up before, but it's a good
No,
one.
I don't remember this one. This one's good.
Okay.
These are 2 aliens looking through telescopes at a house in the distance, and one says, let's not abduct that guy. He looks like a vampire. And the other one says, what guy? Okay, is he become a bat? Is that the reason?
No,
No,
this
it's
one,
Go ahead.
this one has a mirror in it, and vampires don't cast a reflection in a mirror.
Pretty cute.
This one just has a lens, so he can see the vampire, but this one can't because the
Okay.
mirror doesn't capture an image.
Pretty
And
crappy.
a lot of people didn't get that, I would imagine.
I figured his telescope is too high power to see it.
Maybe.
Yeah, we do believe in vampires, don't we? Just not astrology.
Yeah.
Well, gentlemen, there's some breaking news. You want to save the big one till the last, Jerry? The
What's
rest of
that?
it? You want to jump right into the new theories coming out of Hawaii, which link black holes with
Oh,
dark.
you want to do that one first?
Dark energy. Well, if you want to, we can save it for last. Talk about the wild duck cluster or the worm moon. Why don't we do that? Full moon is named after worms for some reason, and it's tomorrow, right? Overnight.
I think it's tonight.
Early tomorrow morning.
Yeah, okay.
So it'll be the end of waxing. We're all waning in our careers, in our lives. Waxing and waning. Okay, what are we going to get? Oh, there it is. Well, that looks like a worm moon to me. Looks just
Yeah,
like all the
same
other
old
ones.
moon. It's a worm this time. This is one of the best pictures I found of the new moon. I mean, the full moon.
Mhm.
And you see different features. You don't see any shadows. So you see albedo changes, brightness changes.
Mhm.
The seas, of course, are dark.
Right?
The highlands are powdered material with rays that are now visible. My dog
Highland-
is barking at the cleaning lady down there.
Yeah,
Highlands are mountains.
Yeah,
Yes.
Yeah, but also just that terrain with the anorthosite that's very white.
Mhm. Is that from Blick, Jerry? Looks like
Is what?
Blick. Is that from Blick Observatory?
this
Hamilton?
one I don't recall where it's from.
Looks like it's from Blick. From the
It's a
refractor.
service that provides photos, and it's in a real faint. The background in the black down here is something stock, public stock or something.
Shutterstock.
Yeah, Adobe stock.
Hmm.
So
Oh,
yeah,
you
that
lost-
doesn't help. But it's a very high quality picture.
Mhm.
Yeah, it is. Can you point out Tranquility Base here? The Eagle has landed. Which one of those?
Right
Mari?
there about 1 o'clock down from the circular one.
Oh, okay. So all 5 or 6 or 7, how many of the Apollo?
There's
14?
Marcrusium.
What?
That- That's Cresium. That's
Yeah.
Cresium.
They
And
all
then come
landed.
down from that. And okay, you see a little feature. It looks like a soccer player. He's kind of lying horizontally. And his shoulder, there's a little feature that looks like a fish grabbing a cookie. And they landed right next to the little cookie. So if you bring your cursor down, up, down and left. Okay, and down now, just straight down, right there. Oh, right there. See the little tiny cookie with the Pac-Man mouth of the fish grabbing it? Just above the point of the cursor.
Okay.
That's where they landed for Apollo 11.
Okay.
Yeah.
Right there, yeah.
Well, it looks like they had a few hills. That's partly white. That's not.
Well, no, they landed in a dark area, but right near the tip of the arrow there.
Oh, and that Lem lander or base is still there. And in
Yeah.
fact, they're all still out there, aren't they?
Yeah.
Be something for future generations to find, and we'll have tourists lined up to watch. To check out Apollo 13. No, 13 didn't make it, but 12 and 14 and 15. And how did it end at 15 or 16?
17.
17. That many times we successfully did it. Wow. The other side doesn't look anything like this. It's all pitted and
It's all the white stuff with just a few small craters that have a black floor.
well, I don't understand that. But
The Russians took the first pictures of the far side, and so they got to name a lot of stuff.
that's true. Okay. Well, as long as they don't have that backwards end in the word.
Mhm.
Fantastic. All right. And we can see this tomorrow night in the sky when the sun goes down, obviously.
You can see it tonight.
Yeah.
And
Be pretty close tonight.
how many days? It's about 3 days of fullness, right?
No, it's just an instant
Yeah.
It's an instant.
technically, but it looks full for about I'd say about a half a day or a full day around the actual event.
Right. The shadows.
Yeah,
are-
tonight will actually look closer than tomorrow night will, because it's at 4 a.m.
Okay.
Yeah.
Your notes said that you can't see many shadows when it's full on, full like now.
I was looking for, I know a lot of craters by sight from their shadows, but only this one, Tycho, and what, Copernicus,
Copernicus.
and
Mhm.
the rest of these Tsiolkovsky or something, maybe. But my favorite up here, Clavius, I hard pick. There's something that might be it there.
Yeah.
It's very hard to identify the familiar features this way because everything is so illuminated differently.
Yeah. So I got a trivia question for Ron.
Okay.
Are you ready?
Yeah.
So
Go ahead.
we're coming up shortly to the equinox, right? The equinox. So if that's the case, where would you look tonight to see this moon rise? Chuck, shut up.
You mean southeast versus east
No.
or south?
Due east.
Okay. It'll be higher in the sky, won't it?
Yeah.
Mhm.
Just the opposite.
But
of
you
the sun.
should look due east for this rising moon, just roughly.
Which
Because, you know,
direction?
coming up in a couple of weeks, it's the equinox. And so nights and days will be separated by 12 hours. There'll be 12 hours apiece.
What is due east from us? Ojai? Or Fraser Park or?
For me, it's Santa Barbara.
Yeah.
For me, it's right out the patio door.
That's
Yeah.
true, you're right. Wow.
Our
And I noticed
coastline
now
runs
that our
east to
church is
west.
rising at 9:30 at night. So it's, we're getting into some nice stuff.
What did you say, Bruce?
I said our coastline runs east and west.
Yeah.
The ocean is
Right.
south.
Yep.
Yeah, when you look at the islands, you're looking south.
And they
So
tell us.
right over here, this is Sinus Iridium, which is the Bay of Rainbows.
Mm-hmm.
And
Bay of
right,
Rainbows.
the prominent point here
Mm-hmm.
doesn't show well in this picture, but in a small scope, like I had back in when I started out as a teenager,
Uh-huh.
it looks like a woman's profile with hair flowing back. But that you can see when it's fully illuminated like this, if you zoom in on this
Mhm.
area. That's about the only prominent feature. Of course, the Apennines here are very visible.
You
What is
guys,
this? Is this Ptolemy?
is what?
I think that's a mare again, like, or a
Okay.
sinus, like iridum.
Yeah.
But I'm not sure.
Okay.
Not a lunatic.
Yeah.
You guys probably have a grand time looking up at clouds and seeing faces and things.
No, I do all the time. I used to do it as a kid, looking up there.
Mhm.
Because we had a ceiling that was real plaster, lath and plaster. And it had a rough finish. So they didn't smooth out all the little lines. And so my mother would get me to take a nap. She'd she'd say that I could find all sorts of things with my imagination in the
Mhm.
random patterns of the ceiling. And sure enough, it knocked me out.
That's why you turned into a physicist, Jerry.
Yeah.
Well, here's another trivia on the moon before we leave it totally for all of you. What was the
Yeah.
name of the area that Dr. Haywood Floyd in the original 2001 Space Odyssey was landing at where they dug up the monolith? What was the name of the area?
Clavius.
Clavius, you just said it. You know,
Yeah, spectacular crater, about half moon,
you might want to take some shovels with us when you, never mind. What's up? What's on the screen here?
So this is the southeast, March 7th, tomorrow at 5 a.m. And
Okay.
it gives you a good preview of what's going to be in the evening in the summer. Whoops. And so we're looking here, the rising of Sagittarius
Mhm.
and Scorpius. And down here, if it's a clear sky, you'll see the false comet. But this thing is about M11, which is right
Yeah.
about here in the Scutum star cloud.
Mhm.
And
Oh, wild duck.
The wild
Yeah.
duck. Yeah.
There we go.
now this is the wild duck cluster, M11. And it's supposed to be named this way because there's a V formation of ducks flying through it.
Mhm.
The only V I can see is kind of here.
No, it's
Yeah.
much bigger. It points up
Yeah.
toward the 10 o'clock position.
Points
Yeah.
toward the center.
10 o'clock.
So that's about here.
Well, it's a big V. It's almost, it's 2/3 the size of the whole cluster.
Yeah, so this is one side of it.
That's one side, and then come almost down, almost straight down for the other one.
Right.
Oh, you
Yeah.
mean this one?
Right there. Yeah.
That's a
Well,
right angle. That's not a V.
Well, these
One
are
of the
geometric
problems-
ducks.
Yeah,
One of the problems about a lot of people who take pictures of these things is they enhance them too much and they squash the contrast. And what you can see with your eye, like this cluster, to me, the wild duck, the V is quite prominent. But
Huh.
here, by the time they've amplified it and done all the things they've done, it kind of blends in with all
See,
the rest of the stars.
if I squint, then, which is kind of like my normal vision, but there's one line here and another line here with the center on this bright cluster here, clump. But then I get another line here, and actually it goes up, it turns from bright to dark and a Y here. So, So I'm picking out all sorts of features, but
No, Bruce is right, Jerry. I mean, there's just too much detail in this image.
yeah, that's because this was taken through a major telescope.
Yeah, yeah.
So
Well, a lot of processing afterwards too.
yeah,
Mhm.
But every white dot on that screen is a star in the Milky Way.
And every
Yeah.
red dot too.
Mhm.
Where are the red
So
dots?
some of those stars around it have gone to the red giant phase. There's a handful of them you can
Uh-huh.
see.
this is a very nicely processed image because the colors of the different stars is maintained.
Yeah,
There's a tendency when you process these images to fade out colors and lose them because you saturate the data from each pixel.
When you do a Control U in Photoshop, that's adjusting colors.
Yeah.
Saturation, yeah.
Yep.
Okay, and so it's a globular or just a
No,
star?
no,
It's an open cluster.
it's open, Ron.
Okay, does that mean no black hole in the middle of it, perhaps?
Well, it means it's young stars and not old stars.
Right,
Mhm.
right.
Clusters are sort of like lumps in the gravy of the Milky Way, aren't they?
Yeah.
Yeah,
Collect-
they're before you, they're in the brownie mix before you split the lumps. No. So this is supposed to be one of the richest and most compact of the known open clusters.
Mhm.
Its age is estimated at about 316 million years, not billion. It's
Okay,
about 4 light years across. And it
6,000
has
light
a
years.
mass between 4 and 11 million solar masses.
Wow.
Mhm.
But the thing is, it's mostly young stars.
Mhm.
The cluster is very metal rich, which will hark back to the
Mhm.
talk we had from Cottam on Friday, with an Fe over H log ratio of 0.17.
Okay.
But
That means these are recycled. There were stars that made the original elements that are now being reformulated in these stars.
it's at least the third generation, which is called population 1 stars.
Mhm.
Exactly, that's backwards.
Yes, it's counterintuitive. It's like one of those things that they named before they knew what they were doing.
Yeah.
And
Thank you.
it's like my favorite example is how when they discovered electric current, they decided it flows in the direction a positive charge would flow. And then
Right.
later they found out that actually it's the negatively charged electrons that flow. But still we have the current convention of positive charge flowing, even though it doesn't.
Well, you can thank Benjamin Franklin for that.
Yeah.
Right.
You
And you
say-
can thank Walter Baade for the population 1. you know.
Yeah.
No, I was talking about that current is the flow of positive charge.
Right, that's Franklin.
But we can
Bought
also,
us for the populations of stars.
Right.
you could also apply it to magnitude, right? Should be opposite. The brighter the star, the higher the number, but it's
Mhm.
just opposite for some reason.
So
Yeah.
in this cluster, the element, the metal richness is enhanced partly by a nearby type 2 supernova explosion, they speculate. Let's see, where is that? The former include 2 eclipsing. Blah, 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 blah. It contains an alpha process from spectroscopy, which is an alpha process decay that goes from carbon to iron by emitting a helium nucleus. That's an alpha particle.
Mhm.
So carbon goes to helium plus oxygen. Oh, I think I have that.
That's that whole CNO cycle, right? Yeah.
That's right, right.
Yeah. So carbon emits a hydrogen, helium element becomes oxygen and
Mhm.
releases 7.16 MeV, million electron volts of energy per single instance. This oxygen then decays to neon, neon decays to magnesium, magnesium decays to silicon, silicon goes to sulfur, sulfur decays
Well,
to
these aren't
argon.
decaying here. These are fusion products here.
Oh, yes,
Right.
well, yeah, transition to, you're
Yeah.
correct on that, yeah. Because you add the hydrogen, the alpha particle.
Hydrogen plus C is carbon?
Yeah, you end up down.
Not hydrogen, helium, Ron.
You start with C as carbon.
What's the C?
Carbon.
Carbon.
It's carbon.
This is a
Number 6.
portion. This is a portion of the carbon iron cycle, or the what they call it, the heat, what did they call it on the last chart? The,
And Ron, another way to
alpha
look at
process
this,
elements.
Ron, if you look at the numbers below the elements there, that's their number on the chart too. So carbon's 6, oxygen's 8,
Right, okay,
10. Okay.
okay, that's the bottom, what do they call the bottom of a fraction, division? No.
No, this is
Denominator.
atomic number and atomic weight.
Right.
Oh, I see, gotcha.
So
It doesn't go through number 7, doesn't become the 7, what's the 7th element? In between carbon and oxygen.
oh gosh, I don't know. Let's see.
Nitrogen, right? It's nitrogen.
I mean,
Carbon, nitrogen, oxygen.
Yeah, nitrogen.
6, 7, 8. 6, 7, 8.
So it doesn't.
So the
become-
key thing of this is that it just involves a helium to cycle from carbon to iron.
Mm-hmm.
Helium has 2 protons, so it wouldn't raise the number of protons by 2.
Yes, it has 2 protons and 2 neutrons. So it has a
Right.
weight of 4 and a number of 2.
Oh, I see, I got you, right.
So if you add 4 and 2 to 12 and 16, you get 16 and 8.
Right. And Ron, you can see the algebra and the bottom numbers. The C plus HE goes to O. 6 plus 2 is 8.
Okay, but something I'd like an answer to, the next to the bottom one with Fe, that means iron, which is we all know is the death knell of stars, right?
Well,
Suddenly,
it's the last,
Yeah.
last element of stability, a
before
large
it
star.
collapses. Why
But
does
if you add helium to iron,
Mm-hmm.
then you get nitrogen.
Yeah. And you do get energy out.
Yeah.
That's nickel. Ni
Yeah,
is nickel.
That's
Nickel,
nickel.
yeah,
there.
excuse me,
That's
God.
nickel.
I need more coffee, guys.
Yeah.
Keep your glasses.
Supposed to make a dime, Ron.
But there's no extra matter involved. Why would it weigh more? Why would the star
It
collapse?
doesn't. Add the numbers up.
Yeah, this is just the nucleus that weighs more.
It gets denser, Ron. It doesn't, there's not more mass. Well, actually, some of the mass
There
is
is
getting
more
turned
mass.
into energy, so there's actually less mass. That little neutrino you see coming out there is actually taking some of the mass away. And this is the energy equivalent over on the right. So it's actually getting less massive, but more dense.
Okay, I
Yep,
can buy
Those
that.
are gamma ray photons, Chuck.
Well, the
Gamma rays, I'm sorry, not
Yeah.
population
yeah.
of the star is changing. So it's becoming richer in heavy elements, in metals.
Yeah. That's right. That's right.
Wow. What are some of the common elements above 26, which is iron? Is aluminum up there above that? Does that get?
Yes, yes.
I don't think aluminum is higher than
Than iron, yeah.
iron, is it?
Ron, I mean, you get platinum, gold.
Yeah.
he-
Lead.
Mercury.
Yeah.
In fact, those are neighbors. Those are all neighbors on the chart.
So those get produced when the star collapses.
Yeah, aluminum's 13.
Well-
It's right next to silicon. And
Very little
Yeah.
gets produced when the star explodes, but when you get the neutron stars colliding is where the bulk of that seems to happen.
yeah,
And my favorite is magnesium there. You see in the third line. That was my dissertation topic.
oh, really? Huh.
Yeah. Yeah, I grew magnesium crystals and did electronic measurements on very low temperature magnesium.
Well, something I do not understand, gentlemen, is when we find elements together, jillions of atoms of the exact same kind are together. How does that happen in a star that they all become magnesium, or they all?
It's
They
not
don't
all
know.
of them, Ron. It's just
Oh, no.
large bunches of them.
Right.
Well, we have, don't we have nuggets of gold that are
Yeah.
trillions of gold atoms thick, and is
That-
anything else?
when the star does this, all the time the star is a star, it is a plasma. So you have nuclei, but no atoms. You have
Right.
lots of electrons, but they're not bound to the nucleus.
Right.
But the nuclei has these energy levels that when things calm down and cool off, the electrons will drop into those energy levels. And
Mhm.
once these particles get out of the sun, out of the star, through an explosion or sloughing off the outer layers, they will then become mostly probably ionized, but to some extent atoms. And then once these atoms are out there in a cloud, they form their own small objects, another sun, for example, a different population sun, or a planet. And it's in the planet where these elements start congregating together, not in the star, because the planet differentiates. You know, it has gravity and it's liquid. So the heavier elements like gold and iron, they settle toward the middle of the planet by gravity. And then you're left with the lighter elements on the outside, the crustal material like silicon and oxygen and stuff. And then you get deposits on the surface through volcanic action or from asteroids hitting.
Birds of a feather.
They're sort of.
Okay.
But not wild ducks.
No.
There's an element called iridium, which came to Earth, or at least a big bunch of it, in that huge rock that killed the dinosaurs.
Iridium
Yeah.
is common in asteroids and uncommon on the Earth's surface.
Right.
Is it above or below the? On
It's
the
a heavy
spectrum?
element.
Okay, it's below iridium.
Yep.
You could do with
Also very
iridium.
hard metal.
Okay,
We
where
used to
are we?
make phonograph needles out of it.
Right. It was first noticed in the Strait of Gubbio, Italy. You know,
Yeah,
by
right.
Alvarez, right? Chuck
The Alvarez brothers, yeah, right?
Yeah.
Or father and son. Father and
Yeah.
son.
Then they found out it's all the way around the Earth. You know, at that depth and age, if you like.
And they wrote a paper saying we got to look for a crater that's about 65, 66
Right.
million years old, million years old. But it's going to be big and we can't find any like that. And a guy who
Right.
went to that talk also went to a talk by some Mexican petroleum industry people who
Right.
said
Yeah.
they had been doing the seismic scanning of the ground looking for oil deposits by setting off charges and seeing how the blast waves behaved.
Right.
And they were seeing this huge crater in the Yucatan. And he said, hey, you guys should talk together.
Yeah, right.
Yeah. And they
That
found
was
shot
Senor
quartz.
Chicxulub.
Yeah, shot quartz in the Gulf and everything, you
Yeah.
know. So there was a big boom 66 million years ago.
The rock as big as it was, what, 6 miles across, they estimate, is
Pretty big.
laid
Yeah.
down a layer of that iridium around the whole world.
Yep.
Yep.
Yeah.
It's thinner on the other side of the globe and it's thicker on the side near the impact area, and it hit at about 30 to 50,000 miles an hour.
Yeah.
Jeez.
Shook the whole place.
And it's mostly in asteroids. Why wouldn't it be down here? We're all made of the same stuff.
I don't know what that was made of, whether it was a different.
Just a quick comment on 11, in a good dark sky, Jerry, you can see that with your naked eye.
The wild
Oh.
ducks. Yeah.
Yeah, the wild ducks.
Yeah,
It's in
I've done that. I just couldn't find the duckness. So
There was
this
one
one,
time there was one time we were at the gun club and you could see the beehive cluster with a naked eye, just as
Oh,
clear
yeah.
as a ball.
uh-huh.
You can see that in the backyard here.
The Greeks
Well-
use that to predict the weather. If you could see it, it's
Yeah.
not going to rain the next day.
Right.
The weather and the light pollution.
Yeah.
That's why it was at the gun club where you could see it.
So we're looking here at the Charioteer Auriga. Now this is, when I look at the sky, I don't see it as these red lines indicate. I kind of borrow the line from Elnath to that. So I see this as a roof and this as the lower portion of it. So it kind of looks like a house, and lifting off from the bottom line of it, because it rotates as it goes through the sky. You get these three very beautiful open clusters,
Yeah.
37, 36, and 38.
Yeah. Yeah.
To me, it's a bent horseshoe.
Yeah.
I don't
me,
have
it's
a line going
Pentagon.
across, but I use Elnath too.
Yeah.
To me, Chuck, is somebody driving a chariot.
Yeah, and holding a goat. Yeah. At least one goat.
Yeah.
So, yeah.
And those M35 up there and the tailbones of Gemini, because that's part of that nice complex of opens, 35, 36, 7, and 8. Yeah. Yeah, Propus is the ankle bone. You know, that's the ankle of Gemini. One of the.
And that's the variable star of the month too.
All right.
Wow.
Yes.
Propus.
Yeah, Propus.
Is the Eta symbol looks like a little N?
Yeah.
Yes, that's Eta.
Has a Geminorium in his orchestra.
When I look up at the night sky and look at Auriga, I see it as a pentagon.
Mhm.
Yeah, that's what yeah, see.
Yeah.
1, 2, 3, 4, 5.
And the brightest of the
How I
bunch,
see it, too.
Capella.
Yeah, Capella, right. Capella's easy to find.
Yeah. It's a beautiful yellow giant.
And it's a variable star because it's got a
There we go.
It's got a partner. I got a binary
Oh,
coupling.
you're talking about Propus now.
Yeah, that's-
This is Eta Geminorium. This is Eta.
Okay.
U, epsilon, kappa, delta, lambda, psi, gamma.
okay.
Yeah.
But this is the one that is a variable star for tonight or for today,
Mhm.
one we're looking at.
It's the past tense of Eta, Ron.
It's
Great.
English pronunciation.
Propus,
This
Pollux.
is it here on the left.
Mhm.
And the galaxy or the nebula close to it.
Okay.
This is an infrared view
Wow.
star over here. That's the same prominent nebulosity again.
Except
That
they're
one's
flipped.
reversed left to right from the previous one?
Yes,
Yeah.
yes, it is.
Somebody used a diagonal.
Or they just flipped it. It's an unusual variable. It has long, bright periods and short, quick, dark periods, but it's not steady and regular like it would be for an eclipse binary, but it looked like that.
It's catastrophic, Jerry.
It's
So
catastrophic.
Yeah, I think that's catastrophic variable. So it turns out that Warren Rogers, and we all know and love him from Westmont, studied this star when he was at the summer science program as a teenager. He actually had data. Unfortunately, his data was lost in the fire, the T fire.
Oh,
He had
Ouch.
wonderful data from this.
But
I think
not-
it's cataclysmic, though. I think it's a cataclysmic variable. if I
yeah, it
remember right.
says it's similar to a Myra variable.
Okay.
Classed is the same.
Yeah, I think the speculation was that it has a companion that has a dusty disc around it.
Yeah,
Okay. Okay.
it's
yeah.
apparently a triple star system.
Yeah.
I've
And
always
from
been worried
visual,
about losing-
you can see this with easily with your naked eye.
Bruce,
I've always been worried about losing data, especially in an event of a catastrophe, whatever it is.
Yeah.
And I back up my hard drive, a clone of it, an actual, bootable hard drive, removable, that sits down in my garage in a fireproof safe. And if we ever have to leave in a hurry, I'll open, the safe doesn't have a combination, it just opens. I'll just grab that drive and take it with me. I can
Yeah.
replace the hardware, but I can't replace the information that's on there.
Yeah. Unfortunately, Warren's data was on paper.
Oh, boy. Well, I scan stuff because I file it, but it's a lot easier to find if I just search my hard drive for the name. I know what the name of it is and I go find it.
Yeah.
could we send you a thumb drive for Christmas? Would that work?
Thumb drives burn in a fire just as nicely too.
Yeah.
That's probably true. This is not a Cepheid.
No,
No,
no, no, no,
It's not.
no.
Those are very regular. This is
Irregular.
catastrophic.
And they think it's because its companion goes in front of it, occults it, sort of.
right. But the companion also has a variable sized dusty disc.
Yeah.
So
And
you
you
can't,
can't-
Ron, brighter is up. Brighter is up. Right.
yeah.
Okay.
Brighter is up. What does that mean?
This is nearly fourth magnitude, and this
Yeah.
appears nearly third magnitude.
Mm-hmm.
So it's brighter up here, darker down there. And
Right.
as someone has said, it's believed to have a circumstellar dust disk around it. Plus the variability of being in a triple star system.
Yeah.
Oh, it's a triple.
Oh,
Yeah.
yeah.
Oh,
So-
okay.
So I don't see this, Jerry, but what's the timeline on this? The back and forth.
You mean from down here, it's 1979, 1980?
Oh, okay. Yes, I can't see
It
that.
looks like it's
Okay.
10 months.
This is September, October, November, December, January.
9 months.
So eight or
You're
8 or
talking
9
many,
months.
many, you're talking many months.
Yeah,
then.
each of these lines is a month.
Okay, okay.
By the way, Chuck, that telescope that I gave you has a prism diagonal in it,
Okay.
so it doesn't flip things.
Hmm.
And
We'll
Ron,
give that away on Astronomy Day.
yeah, Ron, do you know what the definition of,
Yeah.
definition of a prism is?
A prism
Yeah. Yeah, you hear it coming.
depends
that's
on
where
whether
the-
it's low or high risk.
No, no, that's where they keep criminals.
Okay.
Very cool.
What are we looking at here? It's a storm, that's recent storms that hit our county right there.
It's clearing up, yeah. This is a highly magnified section of the Rosette Nebula.
Wow.
And it shows there's a lot of Bach globules in there up in this region. And this is what's an example of a rich star forming region. And the reason it's here is because there was a study that was done and published in, oh gosh, I didn't highlight them. The rate at which the galaxy produces stars is a heavy sign. More stars, the more likely the galaxy is to live longer. So they did a survey of the galaxy by looking at gamma rays from aluminum-26. It rises primarily from massive stars, and studying the distribution of that, they have estimated a larger, by a factor of 4 to 8 times, larger star production rate for the Milky Way than was previously believed, and a higher rate than is predicted or that is observed in neighboring galaxies. So we're a very active star forming. Our galaxy spawns about 10 million to 20 million new stars per year. That's enough to fill roughly 10,000 star clusters like the Pleiades.
Hmm.
Many galaxies, including most of the ones that orbit the Milky Way, make no stars at all.
Really?
Of course, a lot of those are minor galaxies that have had their dust and gas ripped away from them.
What are we looking at again? What part of the,
This is the Rosette Nebula, which is visibly, it's in the sky near Orion's foot.
Yeah, it's in Pupus. Or
Would it be-
Monoscopes.
would it be a fair statement? Would it be fair to say that all of that cloud, those nebulas out there are remnants of past stars? There's no original hydrogen cloud.
No, there still may be some primordial hydrogen out there.
And we'd see it? We'd see hydrogen?
Sure.
Yeah.
It
You're
glows
seeing it
where?
Would that mean the hydrogen atoms are really close together? Aren't they spread apart?
Well, they're spread apart, but you're looking through a hell of a lot of them.
Yeah. It's like a fog, the water droplets are far apart. There's probably several millimeters between water droplets, but you can't see through it well.
Well, I heard that every water droplet requires a piece of matter, a dust particle to form.
Nucleation center.
Okay. Are we going to the BLA here? No, that's not a BLA.
Yeah, this is
New
about
ones.
a 1.8 meter dish made by an amateur named Hap Griffin in the East. And this is what he uses to map the neutral hydrogen in the Milky Way.
Okay.
So this is an amateur one. We had an amateur in our club who made smaller telescopes than this, but he would run them, and you can at these radio wavelengths, you can see stuff at the daytime. It's not ever, the sun doesn't bother it, doesn't interfere with the radio observation. So it's one of those convenient things that you can do during an outreach, like at the museum on Astronomy Day, which we used to do. Do you remember his name, Chuck?
Yuri
Jury.
Polivka.
Yeah, jury.
Yeah.
I've got one of his scopes in my closet. I don't bring it out often because we're usually out at night, but and
Okay. Yeah.
the display is just an ammeter, basically. So you just see a little arrow move
Right.
across the sky. So it's not visually compelling. But when we're stuck under clouds, or if we're doing a science night, quote, quote, night in the spring after the time change, when it's actually daytime, the kids enjoy pointing it around because we radiate in the wave bands that his radio telescope picks up. So they can point it at their friends and see the needle jump.
I don't understand how that little dinky thing you just showed us could bounce radio waves. It was a lattice. We could see right through it.
Well,
Yeah,
no, the
but
radio waves are
the-
longer in wavelength than is the separation
Right.
between the bars.
To a
Yeah.
radio wave, they can't see these holes in the dish.
Really?
Radio wave is so long that this looks like a smooth surface.
Yeah,
Really? Okay.
and the mesh might be on the order of like a centimeter. You know, that might be looking for centimeter information.
Yeah.
And Jerry's
Just
radio
the line
telescope.
he's- Go ahead.
Jerry's radio telescope was made from a kit that uses
Yeah.
a wok.
Yeah.
Huh.
The line he's looking at is the 21 centimeter line of neutral hydrogen.
Oh, okay, okay. Mhm.
Wow.
So
Okay.
that's like what, 8 inches.
Well, I had a
Yeah,
dish.
about that.
These are the new ones that are going to replace Socorro, New Mexico's VLA in time.
This is the new, yes, this is an artist's conception of the NG VLA, the new generation. They're
Uh-huh.
smaller, they're lighter, they're more sensitive, they're more easy to move around.
They're octagons.
They're octagons.
I don't know if it's going to replace, it's going to augment it, I think.
Yeah.
Oh,
Yeah, probably.
doesn't look like
So
they're
it's
laid
going
out
to
in-
consist of 244 18-meter antennas spread over 8,860 kilometers, a baseline.
Wow.
That's 50 something feet across, isn't it?
Yep. It's going to, and when you have an array of dishes like this, the maximum length between the extreme dishes on either end is the equivalent aperture.
Yes.
So it gets a very high resolution.
Yeah.
They're estimating this is going to cost $2.3 billion and an annual operating budget of 93 million.
And they're going to link it with some really far away antennas also.
Yes. So the Earth becomes the essential aperture size for resolution.
Yeah,
Not for,
I saw the Great Array many years ago, and it's just spectacular. You come out of Silver City in the mountains, and you descend towards the desert floor, and you see all of these creatures there. You know,
yeah,
really
this is the existing array.
yeah, yeah. Mhm.
And they've got
yeah.
those on railroad tracks so they can
Right,
yeah.
reposition them.
Oh,
Yep.
no kidding. That's why they're lined up in a row. It doesn't matter how they're lined up.
Well, no, it matters how they're lined up. They just happen to be aligned in a line here, but they can move them around to all kinds of configurations.
Right.
Yeah. And Ron, there's a whole nother array of dishes up in Northern California, almost very close to Oregon, up in Bernie Falls. It's really beautiful. I got a tour of that one time by a graduate student who was working, of course, during the day because it was radio. And he had rollerblades on to go from side to side.
Rollerblades, so it's all concrete instead of a plane. This
Or
is
pavement, yeah.
Yeah, it was all on pavement. Yeah, and they had rails. They had rails to move the
Mhm.
baselines around, you know, to adjust the baselines.
So the
What-
top scientific driver for this enhancement or upgrade is to study terrestrial planet formation
Okay.
and to look at prebiotic chemicals.
Mhm.
every one of those has to be focused on the exact same point in space, don't they? Somehow.
If you want high resolution of one point in space, yes. And
Yeah.
then you track on that, or as the Earth rotates, you let it slide along. And you come back and do another line the next
Mhm.
night.
Mhm.
You build it up slowly.
Yeah.
This is an example of discovery of organic and prebiotic molecules that were seen in space. This is from recent data from Ryugu. And it shows that there are, on this asteroid, there are amines, amino acids, carboxylate acids, PAHs, and nitrogen containing heterocycles, whatever that is. So they're looking for these on new
Somehow
planet.
a zap of lightning eons ago made us, right? Combined them all.
That's an old guess at where our what kickstarted life, where our biological molecules came from. It turns out they come from space, and we don't need to make them up from inorganic chemicals with lightning and all that stuff. But it's still an open question. So
Okay. We're going to get to talk about the new theory, black holes and dark energy.
not a new theory. This is a new question. And that's how science works, by noticing something that doesn't fit and then asking, what the hell is this? So
this will be like string theory, right? It's
no, it looked like that. This is a Einstein ring. It's a galaxy that was seen 1.4 billion years after the Big Bang. And this is the galaxy as it was reconstructed from the distorted ring that's here. This is what the galaxy actually looks like.
Wow.
And it's rotating, and because this is part is red shifted, it's moving away from us. This part is blue shifted, it's moving toward us. So, but the key thing is this is a very, very big galaxy. This is a galaxy that is about the size or bigger than the Milky Way. Now, the idea has been that the Milky Way took 13 billion years to form by eating other galaxies and soaking up dwarf galaxies and stuff. So the Big Bang theory, as it's now envisioned, does not predict this size of galaxy this soon in the universe. So that's the question. How did this form so fast, so big? So there's no answer. But yeah, but
Thanks a lot.
This is the familiar timeline of quantum fluctuations, the sudden inflation, and then the continuing inflation. And so right here in the dark ages, this line here, the first stars formed about 300 to 400 million years.
They pushed that
400.
back.
What's that?
They've pushed that back.
Yeah, this must be an old picture. That's why I stumbled.
I think it is, Jerry.
Yeah. So the fact is this would be about 1.4 billion years right there. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So each of these lines is about 1 billion years. So this is about right for where you see this gigando galaxy. And that's just very puzzling. So there's something wrong with this. Now, there's been wild fluctuations. The Big Bang may be an optical illusion that we're looking at after it happened a long time ago. The laws of physics may be slightly different, or maybe the Big Bang was needs a more complicated explanation.
Mhm.
Or just our version of how stars form needs more work.
Yeah.
Tweaking.
Yeah.
Yeah.
Yeah, was much more, the article that I read said that it was much more efficient than we considered now.
And you may have had direct collapse of gas clouds into black holes,
Yeah.
which explains the gap in the sizes that we see.
Mhm.
And then they may have seeded these big galaxies.
So are we leading into the dark energy thing here, relation with black holes?
We can. This is
Got a whole 6 minutes.
This is a very nice picture of from James Webb, I think, of Andromeda.
It's not a web.
No, it's not Webb because it doesn't have the 6 spikes around it.
Yeah, it might be Galax.
Yeah. Anyway, it's a nice picture.
The black hole.
Yeah, and a black hole. Nice picture. Nice rendering, not a picture. It's an illustration. You know why you see this and this?
Accretion.
On the other side.
Yeah.
That's the backside light being bent.
Right. It has a ring around it like Saturn, but light that's emitted on the backside that goes straight up, it's close enough to the black hole that the black hole bends it around so it comes straight out. So we see the ring on the backside, both above and below the black hole, because the light is bent around from looking. So you have to sit and think about that for a while.
No part of the sky is obscured.
Yeah,
But if that's the center of a galaxy like ours, that's what, the equivalent of 1 billion suns in one spot?
that would be, I think, yeah, 30 billion, no, 30 million solar
What?
masses for the one
You
of our
said-
galaxy.
In our galaxy, it's 4.3 million.
4.3, okay.
God,
I knew there was a 3 involved.
Yeah.
So, no, we got that already. Okay, so that's largely a discussion about the dark energy. There has been it's been noted, we've only got a few minutes here.
these guys are in Hawaii, at least up on the hilltop there, the big island. Is that where the
Yeah.
observatories are?
Well, the key thing is that published in Astrophysical Journal's letters, which is a quick announcement, but in detail, the study is the work of 17 astronomers in 9 countries, led by the University of Hawaii. And they have correlated the expansion of the universe with the growth of black holes. So they believe there's a coupling there. What the coupling is not explained. At least I didn't pick up on it. Got to go back and read the article some more. But they have replaced, in my view, the word for our ignorance of dark energy with another word for my ignorance of cosmological coupling. So there'll be more as we learn more about what that is, the correlation. So the idea is that black holes might contain something called vacuum energy, which is a manifestation of dark energy. This is not a particularly new idea. In fact, it's been discussed theoretically as far back as the 1960s. But the latest work assumes this energy, and therefore the mass of the black hole would increase with time as the universe expands as a result of this cosmological coupling.
Well, vacuum energy is one of the reasons that Hawking radiation occurs.
Yeah.
Could you compare it to a room full of vacuum cleaners that are sucking the air in, but they also have to throw it out the back end?
No, oh, that doesn't work.
That doesn't work.
What goes in the vacuum cleaner doesn't come out anywhere.
Yeah, it does. Sure it does. It doesn't suck the air and keep it.
Called the Hoover
Well, the
effect.
vacuum cleaner doesn't, but the
That's the
black
Hoover
hole does.
You can put the hose on the blowing part
Mhm.
and it blows out.
So
Well, that's an earthly vacuum cleaner. This is a stellar vacuum cleaner. It's very different.
Well, recently it dawned on me that there is matter we can't see, and this is dark matter I'm talking about. It's called air.
no, we can see that.
We can see air.
Yeah,
It's
take a
got
look at the
Johnson
sunset.
lines in it.
Look, that's why the sky is blue. We can see the air.
Mhm.
Kidding.
It interacts with light.
That it was reflecting the ocean.
No.
No.
It's scattering
No.
blue wavelengths of light from the sun.
Is that what it is? Okay, gotcha.
Yeah, keep going, Ron. You're going to have a flat world.
Yeah.
In color astrophotography that I've done at night, like the big picture I took of the Milky Way, the sky overhead is blue.
Okay.
Camera sees color in any light. Our eyes don't see color in dim light.
Plus, auroras are fluorescing atmospheric particles.
Yeah, it's principally nitrogen, right?
Yeah.
About the zodiacal light. That's
No,
not
that's dust out in the.
That's different.
But
Plane
that's
of the solar-
scattered off dust, interstellar dust.
Okay, so there's a relationship possibly. It hasn't been confirmed. How in the world would they confirm black holes and dark energy are together cosmologically?
That's the work that graduate students will be slaving away for a while.
Yes.
Just amazes me. One would think, common sense that all these black holes would be sucking everything away and going the other direction. Jerry, are you lost in thought? Does anybody have any comments on our last minute?
Lost in space, huh?
What's coming up Chuck, what do we got we've had some cancellations, but outreach is slowly regaining momentum here, isn't it?
Yeah, we've got Hollister School and Goleta Valley Junior High this week, and then on Saturday is the star party at the museum, but I think we're going to have some cloud outs.
And then we have a meeting in the afternoon on Zoom next Saturday.
Right, planning
Talk about
meeting.
some things. Well, are we ever going back to Camino Real on a Sunday? Does that happen too?
Well, that's for us on Saturday for Astronomy Day, plus the fourth Tuesday of every month is Telescope Tuesday.
Oh, and we're doing that again.
Yeah.
We are back, ladies and gentlemen, in Farron Hall, but I guess we've added the Zoom and virtual technology because that's what the pandemic gave us. And you guys take care of yourselves and your wives, and I guess we're ready for the drought again. We filled our lake. And thank you very much for enlightening me. Let's do it again next week for number 107. And you have any idea, Mr. President, what we might be talking about next week?
Maybe some more of this vacuum energy thoughts.
Okie dokie.
So-
It's fascinating to me.
Okay.
We're getting sucked into it.
All right.
Yeah,
Well, thank you very much.